Okay guys, this is our second problem for the method of joints. So for problem number 2, basahin ko lang yung problem statement. Via the method of joints, let us determine the loads in all of the members of the truss that is actually being shown. So in this case, we have here a given truss that is actually being subjected to two externally applied forces. So a vertical downward component of force having a magnitude of 45 kN. Then the other one is a horizontal component of force measuring 13.5 kN. So yung truss natin na ito is actually being supported by a pin or hinge at A and then by a roller at C. So once again, to begin with, ang unang-una natin gagawin dito is for us to be able to create the necessary free body diagram. So, kailangan natin free body diagram for us to be able to solve for the corresponding reactions. So, gagamitin kasi natin yung reactions na ito as a given or reference load for us to be able to solve for the corresponding loads in all the members. So, ano ba yung mga members natin dito? So, you have 1, 2, 3, 4, and then 5. So, 5 corresponding members. So, you have member AB, member AD, and member BC, you have member BD, and then you have member CD. So, compared to the last configuration, so sa problem number 1, mas kakaunti yung number of members. However, merong technicality dito. So, along the way, makikita natin yon. So, again, to begin with, so let us create the necessary free body diagram. So, free body diagram. So in this case, gawin natin yung free body diagram. So from the word free body diagram, free natin yung structure from the so-called supports. So support at A. So meron tayong pin or hinge. So dalawang reaction, isang X, isang Y, and then a roller at C. So once again, pag sinabi natin roller, a roller, provided itong roller na to is mounted on top of a horizontal surface, it is subjected to a vertical upward component of a force or that of a reaction. So, since sa A, meron tayong pin or hinge, tapos meron tayong itong horizontally externally applied load, meron tayong idea na yung area of X is directed to the left having a magnitude of 13.5 kN. So, madali lang, babasahin lang natin siya eventually para maka-obtain tayo ng value. So, once again, gawa natin dito ng corresponding signages. So, lumalabas na yung RA of X natin dito is going to the left. So, base yun sa 13.5 horizontally applied load kung saan subjected yung mismong pinaka-truss natin. So, once again, we have 3 equations for equilibrium. So, sulat ko nilang ulit, So, 3 equilibrium equations. So, this is these are very powerful these are actually very powerful formulas in the sense na magagamit natin siya for the vast majority of topics or discussions dito sa tinutukoy nating statics of rigid bodies. So, first one, you have the vertical equation. Second one, you have the horizontal equation. Then, third one, you have the moment summation equation. So, all 3 equations are equivalent to 0. So, yan natin, gawin natin ang solution. So, let's start with the X equation. Summation forces horizontal. All forces going to the right are considered to be positive. So, meron tayo ditong horizontally applied load measuring 13.5 kN. So, since going to the right, positive siya, 13.5. So, positive, negative, array of X. So, since wala na, is equivalent to 0. So, in this case, mamimili tayo So, ang pipiliin natin dito is actually negative. So, you have what? 13.5 minus RA of x is equivalent to 0. So, in this case, lumalabas na yung RA of x natin has a magnitude of 13.5 kilonewton. Ayan. Tapos, base doon sa kanyang corresponding sign convention, ang area of x natin is directed to the left. And the reason kung bakit pinili natin na yung area of x natin is to act towards the left side. Now, kung evaluate natin corresponding configuration, sabi ko ang typical placing ng rollers mounted on top of a horizontal plane surface. So, pagka ganon, meron siyang upward vertical reaction. Pagka ganito naman yung case. Pero pwede magbago yung case niya. Supposedly magkaiba yung orientation o pagkakalagay ng pinaka-roller itself. So in this case, dito sa may C, meron tayo ditong reaction provided by the roller. So lilabel natin siya as RC. So another one is sa A. So again, kung sa A meron tayong pin or hinge, dalawang reaction, isang X, isang Y. So kung titingnan natin, to, lumalabas na yung meron tayong load at the middlemost portion going down. At the other end, meron tayong vertical reaction going up. So, tendency nito para hindi mag-rotate. So, kinakailangan balancehin natin siya. So, ang idea natin dito is yung direction ng area of Y is to go upwards. So, still meron pa rin naman possibility na mali yung consider nating area of Y. Pero in the end, pag lumabas siya as positive, tama yung corresponding assumption. Pero supposedly, ito yung consider nating assumption, tapos lumalabas na value ng area of Y doon sa mabubuo nating equation. Ang lumabas is actually negative. So, re-reverse lang natin yung corresponding sign convention, pero i-retain pa rin natin yung numerical value o yung number. So, in this case, again, RC, lumalabas, vertical. So, area of Y is also vertical. So, non-possible na gamitan natin ng vertical equation. So, instead, gagamitan natin ng moment summation. So, moment summation, you have 1, 2, 3, 4. So, 4 locations or 4 joints, 4 possible moment locations. So, in this case, let's say for example, nag-moment tayo sa A. So, pag nag-moment tayo sa A, mawala area of X as well as area of Y. Lalabas yung 45, lalabas yung 13.5, then lalabas yung unknown which is RC. So, yun nga ang gagawin natin. So, in this case, lumalabas moment summation at A. All forces going the clockwise direction are considered to be positive. So, again, 1, 2, 3, 4, 5. 5 available possible forces. Pero since nag-moment tayo sa A kung saan majority ng forces ay nandoon, mawawala yung dalawa. So, instead, lalabas is 3 from 5 available forces. So, tingnan natin, pag nagkaroon tayo ng rotation, so since along, so lumalabas positive. So, yung 13.5 na sa ilalim ni A, so tendency is sa lubong, So, eventually, negative. So, last one is si RC. So, si RC, since sumasalubong siya to sa direction ng turning motion, ang RC natin is labeled to be negative. So, once again, 45 kN respect to sa direction ng turning motion is said to be positive. So, 45. So, perpendicular distance magmula A papunta sa B, you have 2.4. So, negative 13.5 base nga sa pinakita ko kanina. Tapos, perpendicular distance magmula A papunta dito sa may location ng D, you have 1.8. So, last one is yung RC value. So, na-conclude na natin kanina na yung RC is said to be negative. So, perpendicular distance is magmula A papunta sa D, you have 2.4 plus 5.25. So, you have 7.65. So, 7.65. So, since wala na, sarado na natin equation is equivalent to 0. So, ayan. So, tabi nga doon natin sa calculator kung ano lalabas na value. So, you have 45 times 2.4 minus 13.5 times 1.8 divided by 7.65. So, pag sinimplify, ang value natin ng RC is found to be at a value of 9.41. So, RC value, you have 10.941 kilo Newton. Ayan. So, with respect to sa turning motion, lumalabas is positive. Base dito sa nabuo natin dito. Sa lumalabas, tama lang yung consider nating direction ng RC which is going up. Ayan. So, since nakuha na natin si RC, pwede na rin natin kuhanin yung value ng RA of Y. So, RA of Y. So, RA of Y, doon tayo sa madali. Summation forces vertical o vertical equation. All forces going up are considered to be positive. So, in this case, ilan yung vertical natin? Area of Y, isa. 45, dalawa. RC, tatlo. So, unahin natin yung may mga definite direction. So, negative 45. Tapos, tama lang naman yung direction ng RC. Tapos, let's say, for example, hindi tayo sigurado sa direction ng area of Y. So, kung di sigurado, at dalawa lang naman palagi yung possible direction, positive, negative, area of Y is equivalent to 0. So, negative 45 plus 10.941. So, mas mataas yung number na 45. So, mas mananag yung kanya negative sign convention. So, eventually, yung pipili natin dito is yung positive sign convention. So, positive RA of Y is equivalent to 0. So, tama lang yung judgment or yung decision natin dito na i-project natin yung area of Y going up. So, ang idea palagi is kung meron tayong load that is going down and located at the middle, so most probably kung meron tayong supports at both ends tapos dalawang components na vertical nandun, so most of the time lumalabas na yung reactions doon are both going up. So, 45 minus 10.941, you have 34.059. 34.059. Area of Y, you have 34.059 kilo Newton. Ayan. So, once again, lumalabas dito na value is positive. So, means say, ang mga assumptions na ginagawa natin so far are said to be correct. And now, to check kung tama ba yung ginawa natin, hanap tayo dito ng location. So, para maiba-iba. Say, for example, magmo-moment tayo dito sa may D. So, for checking purposes lang to So, para meron tayong peace of mind para mag-direction So, checking. So, ang di pa natin nagagamit o nagamit pa lang natin so far is A. So, sabi ko nga kanina, 4. So, you have A, B, C, as well as D. So, ang other possible spots or locations para tayo mag-take ng moment summation is yung B, yung C, D. So, let's say for example, sa D. So, moment summation at D, all forces going the clockwise direction are said to be positive. So, ikot tayo. So, tinan nyo lang itong pinaka-tip ng pinaka-pencil. So, since mag-rotate tayo dito, sa lubong yung area of X, ang area of X is said to be negative. negative area of x, magmula dito, papunta dito, you have 1.8. 1.8 is the perpendicular distance. So, ikot. So, positive si area of y. So, distance, you have 2.4. Then, kung titignan natin, no? Though nag-moment tayo sa D at 13.5, lumalabas nandun directly sa may D, hindi magiging part ng moment equation si 13.5 as well as si 45. Kasi kung titignan natin, si 45 na nasa B, ang tendency niya is papunta siya doon sa direction ng D. So kahit saan nyo tingnan, no? Hindi tayo mapagpo-project na perpendicular distance respective sa 45 kN. So meaning say, yung 13.5 as well as yung 45 kN, hindi siya magiging part ng moment summation. Supposedly tayo ay mag-take ng moment summation at D. So last one is yung RC. So kung titignan natin, no? So ikot. Yan. So tingnan yung tip. So ito yung turning motion. So since salubong siya, ang RC natin is said to be negative. RC, perpendicular distance, you have 5.25. Is equivalent to 0. So negative area of x. So negative area of x is you have 13.5. Negative 13.5 multiplied by 1.8 plus area of y, you have 34.059. 34.059 multiplied by 2.4 minus yung value ng RC, which is 10.941. 10.941. So perpendicular distance is you have 5.25 should be equivalent to 0. So kung di man siya totally mag-equivalent to 0, kinakailangan almost equivalent to 0, di ba? So negative 13.5 multiplied by 1.8 plus you have 34.059 times 2.4 minus 10.941 times 5.25. So, yung value natin is you have 1.35 positive 1.35 times 10 raised to negative 3 almost equivalent to 0. So, kung papakita natin siya in terms of yung decimal value, you have 0.00135 almost equivalent to 0. So, meaning say, tama lamang yun na obtain natin mga values dito. So, check. So, after ma-obtain na natin yung mga corresponding reactions, once again, no, there's a need to solve for the corresponding reactions kasi in most cases o most of the time, ginagamit natin itong mga reactions na to as the given value para maka-obtain tayo ng unknowns, no? So, susunod natin dito, no, since nakuha natin mga corresponding reaction, gagamitan na natin ng isolation on the corresponding joints. So once again, bilangin natin joints. So in joints natin, you have A, you have B, you have C, you have D. So since apat yung joints, so ito din magdidictate or magsasuggest ng number of maximum possible isolation. So in this case, you have 4 maximum number of isolations, so 4 number of isolations that could be done on the joint itself. So, di naman kinakailangan kuhanin yung isolation on all joints, pero for checking purposes, ginagawa natin is kino-consider natin lahat ng joints, di ba? So, another one is, let's say for example, ganito, no? Kung mamimili man tayo ng joint itself, mamimili tayo ng joint bearing or having the least number of members. So in this case, na malabas, ang joint A, dalawa yung member, you have AB, you have member AD, tapos dalawa yung reference load. So in terms of area of X, in terms of area of Y. Whereas sa C naman, kung titignan natin, same case. However, ang difference lamang ng dalawa is instead na dalawa yung reference load, dito is isa lamang yung reference load in terms of RC. So mas piliin natin to kasi lumalabas habang kumakaunti yung mga numbers, mas nagiging simple or simple o less complicated yung mabubuo nating equation. So in this case, ang gagawin natin dito is, let us start to have an isolation on joint C. Diba? So, yun nga gagawin natin. So, start off yung isolation at joint C. So, lagay lang natin ng statement. Start off with isolation at joint C. Ayan. So, gawin natin yung gagawin natin. So, gagayahin natin yung drawing dito sa joint C. Yan na. So, ginagaya na natin. So, RC natin is you have 10.941. So, 2P lang natin yung figure para mas madali natin basahin mamaya-maya. So, RC you have 10.941 kilonewton. So, sunod na natin yung iba. So, CD tayo. Ito yung CD. Tapos, member BC. So, lagyan natin ng label para hindi tayo masyadong malito, no? So, BC, ito naman is you have CD. So, CD to. Then, ito naman si BC. Ayan. Then, itong part or point na to, ito yung joint at C. Ayan. So, extend lang natin yung corresponding lines natin dito para magamit natin yung triangle dimensions, right triangle dimensions, para once na magkaroon tayong breakdown ng x at y components, lumalabas, wala tayong encounter na difficulty. No? Ayan. So, kung titingnan natin ngayon, no? Extend natin yung line dito. Ito na ngayon yung right triangle dimension. Extend din natin yung line dito, hindi yung right triangle dimension. So, in both cases, lumalabas 5.25 yung kanyang adjacent side. 5.25. Then, yung opposite side, kung titingnan natin dito sa configuration, opposite side is 1.8 para dito sa triangle BC. Tapos, para dito sa triangle CD, ang opposite side is 1.8. So, in both cases, 1.8. 1.8. Ayan. So, let's say for example, gusto natin kuhanin yung corresponding angle. Kuhanin natin angle dito. Ito, no? Kuhanin natin yung angle dito. So, kung ano yung angle dito, yan. Yun din kung ano yung angle dito, yun din magsisilbing angle natin dito. So, in this case, lumalabas, angle dito, ito yung adjacent side, ito ngayon yung opposite side. So, OA, so tangent ng angle na ginagamit natin instead of x palagi, no? TOA, opposite all over adjacent. So in this case, lumalabas, you have the Opposite side. Opposite side natin dito is 1.8. Then adjacent side is you have 5.25. So tangent ng angle. So kuhanin natin corresponding angle, no? Kuhanin natin angle. So you have 1.8 divided by 5.25. So kung gusto natin kuhanin angle, inverse tangent ng value. So 18.925. 18.925 or 18.92 na lang. 18.92 degrees. So, asan yung 18.92 degrees na yan? So, yung 18.92 degrees na yan, basically is ito. So, pakita natin. 18. Medyo nagkamali. Gamitin natin ang correction tape. Mali ulit. Sorry. So 18.92. So kung titingnan natin dito, no? Kung ano yung angle natin dito, basically is yun din magiging corresponding angle natin dito. So in this case, ano, kung ano yung angle dito sa side na to, do sa opposite side naman niya, sa reverse, yun din magiging corresponding angle niya. So in this case, basically, lumalabas paras lang ng angle. So angle natin dito is you also have 18.92 degrees. So 18.92 degrees. So ito na, no? So kung i-evaluate natin yung configuration, meron tayong ma-encounter na dilemma or problema. Ano yun? So meron tayong isang vertical, meron tayong dalawang inclined. So dalawang inclined, ang problema pa natin, hindi natin alam kung si BC is actually in tension or via compression. So the same goes or the same thing applies dito sa may inclined part or member natin, which is CD. So in both cases kasi, since dalawang incline natin, i-breakdown natin sila sa mga respective X at Y. So in both cases lumalabas, merong Y component si BC in terms of BC of Y, meron ding Y component si CD in terms of CD of Y. So kung tayo man ay magtitik ng summation forces vertical, malabas, ito nga yung reference load natin, which is RC. So hindi naman din possible kasi dalawa yung unknown natin. So meron tayong reference load in terms of RC, pero lalabas si BC of Y as well as si CD of Y. So in case na meron kayo may encounter na ganitong klase ng situation, so the best thing to do is actually gagawin natin dito, magkakaroon tayo ng reconfiguration. So pag sinabi natin reconfiguration, i-rearrange lang natin configuration. So meron tayo dito i-consider as the new axis from the previous axis. So ang gawin muna natin dito is, let's say for example, ganito. Pag tinignan natin ngayon muna yung ating illustration or yung configuration, since ito naman is horizontal line, it is perpendicular. So base dito sa corresponding symbol o line yung ginawa ko, itong RC with respect dito sa horizontal line is said to be perpendicular. So in this case, since itong value nito is 18.92, meron tayong idea kung ano ngayon yung matitira dito sa kabilang side, no? So let's say for example, lambda. So lambda, para makuha natin, is equivalent to 90 degrees minus theta of x, which is 18.92. So 90 minus 18.92, so lalabas mo niya 71.08. So lambda, you have 71.08 degrees. Yan. So yung angle natin dito, ang value niya is 71.08 degrees. So 71.08 degrees. So ito gagawin natin, no? So ang gagawin natin dito is meron tayo ditong dalawang inclined members. So yung dalawang inclined members na to, meron tayo ditong isang member kung saan gagawin natin siya as the x-axis. So magkakaroon tayo ng tinatawag nating reconfiguration. So lagay lang natin ng worded statement via reconfiguration. So lagay natin ng word via reconfiguration. Via reconfiguration with member CD being the x-axis. Yan. So ang gagawin natin dito is yung CD, gagawin natin siya as the x-axis. So tatabingin lang natin siya. Yan. So para mas madali nating basahin yung configuration, may ginawa ako ditong separate illustration. Tapos gagayahin na lang natin. So para makita nyo na maayos yung pagbe-breakdown, ano? So joint C to. So lagyan lang natin ng statement joint C. Joint C. So joint C pa rin to. So joint C pa rin siya. Pero ito na gagawin natin, no? So yan. So in this case, lumalabas yung CD na dating inclined, nagiging horizontal na siya. Then gagayahin lang natin. So kinakailangan pag nag-drawing, kinakailangan approximately ma-reciprocate natin yung mga corresponding angles, kasi once na kayo ay gumawa ng illustration without properly illustrating the correct angles, baka mamaya pag binasa natin to parang malayo sa katotohanan, no? So kinakailangan properly babasa ng maayos. So ito ngayon si 10.941. Tapos ito ngayon si CD. Ayan. Tapos yung kabilang side, ito ngayon yung BC. Diba? Mas madali siyang tingnan. Ayan. So ito si member BC. Ito naman si member CD. So papakita lang natin yung breakdown ng angle. So kung titingnan natin, no, combine na natin yung dalawa. So 18.92 dito, 18.92 dito. So you have 18.92 times 2. So you have 37.84. So ito, ang angle natin dito is you have 37.84. So 37.84 degrees. Whereas ito, no, so nakikita naman natin na yung angle respect dito sa line CD, green line CD, saka dito sa may red vector RC is ang angle niya is 71.08. So 71.08 degrees. 71.08 degrees. So, ito is si member CD. Ito naman si member BC. Ayan. So, yung problema natin kanina na dalawang inclined tapos yung reference load natin na vertical. Ito naman, ang panibagong configuration natin is ganito nangyari. Yung RC na dating vertical naging inclined. RC is 10.941 kilo Newton. So, gaya nga sinabi ko sa inyo before, pagka-start meron tayong inclined force, ang gagawin natin dito is we are going to break this up into its X and Y component of force. Pero ang tanong dito is technically, ano ang unahin natin? Vertical equation or horizontal equation? So, once again, re-remind ko lang kayo na ang paggamit ng moment summation pagdating sa method of joints hanggang dito lang sa pagkuha ng reaction. Whereas pagka nag-start na tayo ng isolation on the part of the respective joints, ang gagamitin na lang natin formula dito interchangeably is yung vertical equation saka yung horizontal equation. So tingnan natin, no? So in terms of yung x, so lumalabas merong x component yung given na paggagamitan natin. So CD horizontal lalabas magiging part ng horizontal equation. So yung another unknown which is BC, since inclined siya, lalabas din yung kanyang BC of x. So instead of trying to start off with the horizontal equation, ang gagawin natin dito is mag-start tayo in terms of yung vertical equation. So summation forces vertical, all forces going up are considered to be positive. So ang gagawin natin dito is be-breakdown natin. Ito. So breakdown ito. Ayan. So, ito siya. So, lumalabas, kung ito ay si RC, lumalabas ito si RC of Y. Or, ang gawin natin is gamitin na natin yung actual value niya, which is 10.941. So, in this case, 10.941 of Y. No? 10.941 of Y. So titingnan natin, no? Ito, no? By the way, para mas maintindihan yung concept, supposedly meron tayong rectangle dito. At ang gagawin natin sa rectangle is da-dissect natin into two right triangles. Kung ano man yung angle natin dito, yun din basically yung magiging angle natin dito. So in this case, ang angle natin doon sa kabilang side is you have 71.08. So kung ito is 71.08 degrees, ito also measures 71.08 degrees. So para makita nyo lang yung breakdown. So ang ginagamit kasi natin angle dito is respect yung sa theta, no? So ito also measures 71.08 degrees. So, summation forces vertical, lumalabas, ito yung data, ito yung given. So, since going up, positive, 10.941 of Y. So, since dalawa lang naman lumalabas, nabubuo ng ating vertical equation, at yung isa is BC of Y. So, BC of Y yung isa. So, sasaran natin kasi dalawa lang sila. So, kung mamimili man tayo, positive or negative, ang pipiliin natin dito is actually yung negative sign convention. Diba? So, in this case, lumalabas, you have what? You have positive 10.941 of Y. So, since given naman yung angle, instead na equivalent value ng sign ng angle, ang gagawin natin dito is sin na. So, kasi pagka Y is sin, pagka naman X is cosine. So, sin ng angle? 71.08. 71.08 minus BC. Tapos, breakdown natin yung Y. So, you have sin. So, yung angle naman niya is you have 37.84. 37.84 degrees is equivalent to 0. Diba? So, in this case, pwede na natin kuhanin yung value ng BC. So, 10.941 sine ng 71.08 divided by sine ng 37.84. So, ang value is you have 16.871. 16.871. So, BC value is you have 16.871 kilonewton. Ayan. So, base dito, no, ang pinili natin BC of y is actually negative. So, pagka negative, base dito sa ginagamit nating vertical equation, going down. So, meron tayong ngayong idea na yung BC of y is actually going down. So, lagay natin dito. So, BC of y is going down. Now, since nag-giveaway na ngayon yung y component ng BC, yung BC of y na to, ito na ngayon yung magbibigay ng idea kung saan papunta si BC. So, once again, dalawa lang naman yan eh. So, up or down. So, since yung y component is going down din to. So, yan. So, ito ngayon si BC. Diba? So, yan. So, natapos na tayo ngayon sa ating vertical equation. Sunod na natin si horizontal equation. Summation forces of x, all forces going to the right are considered to be positive. Yan. So, in this case, ilan yung horizontal component of force? So, start muna tayo dito sa given value. So, yung RC, inclined, yung given, o yung reference load, breakdown natin siya. So, in this case, you have 10.941 of x. Now, since yung 10.941 of x is directed to the right, positive 10.941 of x, diba? Now, kung titingnan natin, since na-establish na natin yung BC is going down, meron tayo din ngayong idea na yung BC of x is going to the right. Ayan. So, ito is to be labeled as BC of x. So, plus BC of x. So, ang susunod natin is yung CD. So, no need na i-break down CD kasi yung CD natin is already horizontal. So, meaning say, wala siyang y component. Diba? So, di na kailangan i-label to as CD of x, rather CD na lamang. So, sabihin natin hindi pa tayo mapag-decide, positive or negative CD is equivalent to 0. So, since positive yung isa, positive yung isa, short ball na tayo na yung gagamitin natin sign convention is negative. So, you have 10.941 of x plus BC of x minus CD is equivalent to 0. So, breakdown natin. Kung kanina, in terms of y, sine. Ito naman, in terms of x, magiging cosine. So, positive 10.941 cosine ng, gaya na lang angle na ginamit, 71.08 plus BC value, you have 16.871. So, cosine ng 37.84. Minus CD is equivalent to 0. So, compute natin, no? 10.941 cosine ng 71.08 plus 16.871 cosine ng 37.84. So, you have 16.871. So, same lang din lumaba, 16.871. So, 16.871 yung CD. So, positive 16.871 minus CD is equivalent to 0. So in this case, CD, you have 16.871 kilonewton. Ayan. So nakalimutan natin specify kung yung BC ba is either compression or tension. So again, may I remind you na pagka yung direction ng vector o ng arrowhead is papunta sa joint that is actually being considered, ang tawag natin doon is compression. So kung palayo naman siya, ang corresponding effect naman niya is via tension. So kung titingnan natin, si BC papunta sa direction ng joint C na kinonsider natin, so ibig sabihin, ang effect nito is via compression. Ayan. Then, tingnan natin, no? So, base kasi dito, ang napili natin is negative. So, sa X equation, pakanan is positive. So, meaning, pakaliwa is negative. So, meaning say, dadirect ngayon natin yung CD going to the left. So, meron tayo ngayong idea na yung CD natin, since yung arrowhead niya, o yung vector ay papalayo do sa joint C that was actually being isolated, lumalabas yung CD natin is via tension. Yan. So, nakakadalawa na tayo, no? Yan. So, gawa pa tayo ulit isang isolation. So, ang gawin muna natin dito is i-revert natin, balik na natin sa dati yung ating yung reconfigure natin para pagka kinonsider na natin yung corresponding vectors pagdating sa mga respective or succeeding isolations, hindi na tayo malilito. So, lagyan na lang natin statement, no? So, reverting to old axis. So, reverting to the old axis. So, RC natin, you have 10.941. 10.941 kilonewton. Tapos, si CD natin tension. Ito siya, no? Yan. So, CD value, you have 16.871 kilonewton. So, last one is yung BC. So, BC is via compression. So, BC, you have 16.871 kilonewton. Ayan. So, ayusin na lang natin yung configuration para for presentation purposes. So, once again, angle natin dito, you have 18.92 degrees. Whereas itong angle naman natin dito sa kabilang side, you have also the same angle, 18.92 degrees. Ayan. So, this is actually joint C, diba? So, ayan. Yun ang buo nating isolation. So, after nating ma-isolate yung C, so, ang choice natin dito is pwede tayo mamili between B as well as D. So, kung bibilangan natin sa B, you have 1, 2, 3. 3 members. So, 3 vectors yun. Then, your reference load which is 45. So, 4. So, sa D naman, so 1, 2, 3. 3 members. Tapos, sa meron tayong reference load which is 13.5 kilonewton. So, in this case, lumalabas, pares lang ng concept o pares lang ng scenario. So, lumalabas, 4 yung corresponding forces. Para let's say, for example, ang pinili natin dito instead na B, ang pinili ko is D. So, D ang pipiliin natin, ha? So, ang gawin natin dito is magkakaroon tayo ng isolation at D. So, joint D. So, joint D, ang mangyari dito is, ito yung isolate natin, no? So, ito siya. So, 1, 2, 3. So, gayahin natin siya, no? Para mas maayos yung presentation natin. Ayan. So, ito na siya, no? So, gayahin natin ngayon yung externally applied load na 13.5. Ayan. So, 13.5 kilonewton. So, lagay natin 13.5 kilonewton. Diba? So, si CD. Ata. So, CD natin is tension. So, ito siya, CD. So, ito ngayon yung panibagong CD natin. So, CD, kung titignan natin, kulay green. So, para mas maganda yung presentation. So, again, no? So, CD natin is via tension. So, kung ang kinoconsider natin dito is yung joint D, which is basically ito. So, from the word tension, yung CD natin is going up or going in the northeast direction. So, CD. So, CD value, meron tayong CD value. CD, you have CD natin is you have 16.871. 16.871 kilonewton. Ayan. So, ito, no? So, itong vertical member na to, yung vertical member is considered to be member BD. So, ito si BD. The last one is ito, si AD, yung inclined. So, AD. So, lagay natin AT. Diba? So, once again, dalawa na lamang yung natitirang formula. Dalawa lang yung formula gagamitin natin kasi hindi na ginagamit yung summation moment. Once again, sa method of joints kung nasa mismong isolation na tayo ng joint itself. Diba? So, tingnan natin, no? Ano ba ang pwede natin unahin? Vertical equation ba o horizontal equation? So, in terms of the vertical equation, lalabas si BD, lalabas yung y component ng AD, which is AD of y. So, cannot be. So, not possible na tayo mag-start sa vertical equation. So, meaning to say, mag-start tayo sa horizontal equation. So, summation forces horizontal, all forces going to the right are considered to be positive. So, ano na yan? So, meron tayong idea na yung 13.5 is positive kasi going to the right. So, yung CD of X. So, yung X component ng CD going to the right. So, lagay natin dito is CD of X. So, since yung CD of X saka yung 13.5 kilonewton are both going to the right, meron tayong idea na yung AD of X is going to the left naman. Diba? So, instead na unahin ko muna yung pag-affix ng sign convention, ng vector o arrowhead direction, buuin muna natin yung ating X equation. So, lumalabas, positive 13.5, positive CD of X. So, again, let's say for example, mamimili kasi hindi sigurado. Although, meron tayong idea at AD of X yun, AD of X. So, AD of x. So, since wala na, is equivalent to 0. Diba? So, positive, positive. So, pipili natin dito is negative. So, consider na natin yung mga corresponding angles, no? So, check muna natin. So, in terms of yung angle, so, kailangan kasi natin yung angle. So, tingnan natin. Yan. So, ang opposite side nito is you have 1.8. Ang adjacent side naman is you have 5.25. So, opposite side is 1.8, adjacent side is 5.25. Opposite all over adjacent, 5.25. Inverse tangent, tayo, no? So, 18.92. So, yung angle natin dito is 18.92. So, 18.92 din to. So, lagay natin na yung angle dito was found to be at a value of 18.92 degrees. Ayan. So, computin na rin natin angle doon sa kabilang side kasi babalik. Dadaan at dadaan din naman tayo doon eh. So, adjacent side, you have 2.4. Opposite side, you have 1.8. So, opposite adjacent. So, 1.8 divided by 2.4, 3/4. So, inverse tangent. So, 36.87 degrees. So, yung angle naman natin dito is you have 36.87 degrees naman. Ayan. So, na-complete na natin yung corresponding angle. So, lipat na natin siya dito. So, once again, yung angle natin dito is you have 18.92 degrees doon sa may right side. Sa may left side naman, you have 36.87. So, 18.92 degrees. Ito naman is you have 36.87 degrees. Ayan. Diba? So, breakdown na natin. So, you have what? Positive 13.5 plus CD of x. CD of x is CD value. Meron na ba tayong CD value? So, CD value. Meron na. So, CD value natin is you have 16.871. So, 16.871 of x. So, cosine to, no? Cosine. At ang angle is you have 18.92. So, minus AD. Breakdown ko na yung x ng AD. So, cosine. Cosine at ang angle is 36.87. So, since wala na, is equivalent to 0. So, pwede yan tayong magpipindot, ano? So, 13.5 plus 16.87, 871 rather, cosine ng 18.92 divided by cosine ng 36.87. So, you have 36.824. So, 36.824 as the value of AD. AD, you have 36.824 kilonewton. Ayan. So, AD is found to be at a value of 36.824. Now, tingnan natin, no? Ang pinili natin sign convention AD of x is negative. So, again, pakanan is positive. So, mean say, ang AD of X natin, the divert natin going to the left. Yan. So, meaning, since yung X component ng AD natin is going to the left, meron tayong ngayong idea na yung AD natin is going away from joint D. So, mean say, kung papalayo, ang overall effect niya is in terms of tension. Yan. So, tapos na tayo sa vertical equation. Ang susunod natin is yung tinutukoy nating horizontal equation. Ang susunod natin is vertical equation. So, summation forces vertical, all forces going up are considered to be positive. So, ano na yan? So, hindi na counted si 13.5 kN kasi 13.5 kN na externally applied load na kung saan subjected yung pinaka-truss natin is horizontal. So, lumalabas ngayon, ang papatak o lalabas is yung CD of Y o Y component ni CD, yung Y component ni AD, then last one is yung value ng BD. Now, kung nakikita nyo, since yung CD natin is going up, ang Y component niya is going up. So, since yung AD natin is going up, yung AD of Y is also going up. So, up si AD of Y, up si CD of Y. So, CD of Y, up, AD of Y, up. So, ang pangontra natin is si BD. So, walang ibang direction si BD. Rather, ang direction ng BD natin is going down. So, CD of Y. Diba? Tapos, ito naman si AD of Y. Yan, AD of Y. So, mamaya ko na ilalagay yung corresponding arrowhead ni BD. Unahin muna natin buuin yung ating vertical equation. So, lumalabas, positive AD of Y, positive CD of Y, positive negative BD is equivalent to 0. Yan. So, again, ang pipili natin dito is yung negative para mag-0, diba? So, in this case, lumalabas, you have what? Positive AD of Y, positive CD of Y, minus BD is equivalent to 0. So, AD value, you have 36.824. So, 36.824. So, once again, pag breakdown natin yung Y, you have sine. So, tingnan natin, AD, ang corresponding angle ng AD is 36.87. So, plus CD value. So, CD natin, you have 16.871. So, 16.871. So, Y, sine. Sine. Then, yung corresponding angle is you have 18.92. So, minus BD is equivalent to 0. So, tabulate na natin. So, 36.824 sine ng 36.87 plus 16.871 sine ng 18.92. So, you have 27.565. So, BD value, you have 27.565 kilonewton. Ayan. Now, yung pinili nating sign convention ni BD is negative. So, pagpataas is positive. So, mainly say, meron tayo ngayong idea na yung BD value is going down. Ayan. So, since yung direction ng BD is papunta doon sa direction ng joint at D, so, ang ibibigay niyang corresponding effect is by a compression. So, compression siya. So, tapos na tayo sa joint at D. So, meaning say, pwede tayong tumalon ulit. So, ang gagawin naman natin is tatalon tayo sa may joint at B. So, joint B tayo. Joint B. So, joint at B. Ayan. So, joint B tayo, no? So, gagayin lang natin yung isolation ng joint B. Ito, no? So, joint B is yan. So, joint B. So, ito. Yan. So, 45 kilonewton going down. Yan. So, BC. Ito si BC. Ito si BD. Ito naman si AB. So, tingnan natin so far yung meron tayong mga values na meron, no? So, in this case, you have what? BD. So, yung BD natin is via compression. So, lagyan muna natin yung 45 kilonewton external applied load base doon sa corresponding configuration natin. Yan. So, 45 kilonewton. So, BD, ang BD value is compression. So, base dito, no? So, BD, kulay blue, yan natin. So, via compression, yan. Via compression, so, sulit natin. BD, you have 27.565 kilonewton. So, BC, no? So, BC, gawin natin kulay red. So, BC, so, kung titignan natin, ang BC is via compression. So, compression, papunta doon sa joint at B, compression ulit, no? So, BC value, you have what? 16.871. 16.871 kilonewton. Yan. So, ang kulang na lang natin dito basically is what? Ito member AB. Diba? AB na lang tayo. So, AB. So, yun nga gagawin natin. Ayan, si AB. Ayan, no? So, ganyan lang natin yung mga corresponding angle. So, angle lang consider natin. Ito, no? So, yan. So, titignan natin. Pares lang naman yung triangle dito kasi 5.25 yung adjacent side, 1.8 as the opposite side. So, kung ito is 18.92, lumalabas 18.92 din to. So, 18.92. So, kung titignan natin, 2.4 yung adjacent side, 2.4 yung adjacent side, 1.8 yung opposite side, 1.8 din dito. So, mean say, kung ano yung angle natin dito na 36.87, yun din yung makikita natin angle dito. Diba? So, 36.87 degrees. Yan. So, angles natin is 18.92 sa may right side, 36.87 doon naman sa may left side. So, gagayahin natin yan. So, ito, no? So, you have here 18.92 degrees. Ito naman is 36.87 degrees. Ayan. So, ang problema nang natin dito is so far wala tayong value ng AB. The rest, meron na, no? So, titignan natin ngayon dito, yung AB, pwede natin kuhanin in two possible ways via sa x equation and then via sa horizontal equation. So, ang titingnan natin dito, mas kakaunti yung horizontal. So, technically speaking, walang direct horizontal forces. Pero, kung titingnan natin, meron tayong inclined vectors. So, yung inclined vectors, once i-break down natin, meron siyang x and y. So, sabihin, ito, no? So, si BC going to the left. So, si BC of x going to the left. Yan. Diba? So, meron tayong ngayong idea na si AB is going to the right. So, kung AB is going to the right, so, yung AB natin is via compression. So, unahin muna natin dito is bumuo muna tayo ng horizontal equation. Summation forces vertical, mali no? Horizontal. Summation forces horizontal, all forces going to the right are considered to be positive. So, napaghalo natin. Sorry, once again. Yan. All forces going to the right are considered to be positive. So far, ang pagkukuha natin dito ng values yung BC of x. So, since directed to the left, negative BC of x, di ba? So, since dalawa lang naman yan, at yung isa is siya AB of x para mag-0, at kung once again, mamimili tayo, ang pipiliin natin this time around, kasi is palagi tayo negative, is actually positive, di ba? So, in this case, lumalabas BC of x, negative BC of x, positive AB of x is equivalent to 0. So, BC, so, ang BC value natin is you have 16.871, negative 16.871. So, in terms of x, cosine. Tapos, ang angle is 18.92. Cosine ng 18.92 plus, you have what? Yung unknown, which is AB, cosine pa rin, kasi x ano. Tapos, yung angle naman niya is 36.87. So, since wala na, is equivalent to 0. So, in this case, equate na lang natin yung both sides. So, dito tayo sa calculator, 16.871 cosine ng 18.92 divided by cosine ng 36.87. So, ang value is 19.95. 19.95. AB value, we have 19.95 kilonewton. Ayan. So, ang kinonsider natin dito ang value ng AB of x is actually positive. So, base doon sa ating x equation, pagka positive is going to the right. So, kung going to the right, ibig sabihin, yung AB of x natin is ito na. So, ito ngayon si AB of x. So, since nag-given na ngayon yung x component ni AB, ito na ngayon magsasuggest na si AB natin is also going to the right. So, going in the northeast direction. So, ayan. So, meron tayong yung value ng AB. So, since yung direction ng AB natin is pupunta doon sa joint B itself, B. So, ang corresponding effect ni member AB, yung member AB natin is under the force of compression. Ayan. Diba? So, last one is yung ating vertical equation. So, summation forces vertical. All forces going up are considered to be positive. So, ano na yan? Unahin muna natin yung positive BD. So, positive BD. So, negative 45 na load. Tapos, yung BC of Y going up. So, let's say for example, ang inuna natin dito is yung Y equation at hindi yung X equation. So, mamimili tayo ng AB of y. Pero from the looks of it, lumalabas ang AB of y natin is going up. Pero let's say for example, nag-start tayo sa vertical equation. So lumalabas, hindi tayo sigurado, positive, negative, AB of y. Then since wala na, is equivalent to 0. So BD value, you have 27.565. So positive 27.565 minus 45 plus BC. So BC value natin is once again, you have 16.871. So Y, be-breakdown natin, Y is sine. So BC, ang angle involved is you have 18.92. So hindi pa tayo sigurado. Kunyari, hindi pa tayo sigurado sa AB of y, positive, negative. AB of y. AB of y is, mamaya na natin breakdown. So AB of y is equivalent to 0. So simplify muna natin. So you have what? So you have 27.565 minus 45 plus 16.871 sine ng 18.92. So yung value is negative 11.965. Negative 11.965. Tapos ang pipili natin dito is, since ito is negative, ang pipiliin natin is positive, which is technically said to be correct kasi ang AB of y natin dito is going up base dito sa direction mismo ng resultant force natin on a vector AB, which is going to the right or going the northeast direction. So positive AB of y. So AB, so breakdown natin yung mamaya natin breakdown. So AB sine ng 36.87 is equivalent to 0. So in this case, lumalabas lumalabas na yung AB value natin. So fully 19.95 din siya. So gamitin ko na to yung kanina, no? Di-divide lang natin sa 36.87. So 11.965 divided by sine ng 36.87. So, ang value is 13.942. So, 13.942. 13.942. So, rather, ang value pala is 19.942. 19.942 kilonewton. Ayan. Now, since ang pinili natin dito sa sign convention is positive, so base dito sa sign convention, pagka vertical, ang going up is positive, diba? So, ito ngayon si AB of y. So, base dito ngayon sa direction ng AB of y, which is going up. So, still, na-prove natin na tama si AB, which is going up also, going in the northeast direction. So, since yung direction ng arrowhead ng AB natin is pupunta doon sa joint B itself, ang corresponding effect niya is via compression. Ayan. So, tapusin na natin yung ating discussion for this particular problem. So, huli na natin. Consider na natin yung last joint that has yet to be isolated, at yun yung kanina pinagpilian natin, which is at joint A, di ba? At joint A. So joint A, kung titingnan natin is you have what? 1, 2, 3, tapos 4. So, gawin na natin, no? So, base dito, no? Area of y is going up. Area of y natin, base dito, you have 34.059. Tapos ang area of x natin is going to the left. So area of x is you have 13.5 kilonewton. 13.5 kilonewton. So, ang consider na lang natin dito is yung member AB. So, yung ginamit natin color dito sa AB is green. So, gamitin din natin yung green. Tapos, AD. AD naman, no? AD naman is kulay red. So, green saka red. So, green sa taas. Green sa taas. Tapos, red. So, hindi na pwedeng red. So, gamitan na lang natin ng blue. So, yan. So, A dito. Samantalang ito namang isang to is you have AB, yung green. Yan, AB. Diba? So, say for example, kung consider natin yung mga corresponding sign convention, tapos puprove na lang natin na sila is 0. Ang AB is by a compression. So, AB compression. Yan. At ang AB value is found to be at a value of 19.95 kilonewton. Samantalang yung value ng AD, ito yung AD natin, no? AD. So, AD value is you have 36.824 via tension. So, via tension, 36.824. Yan. So, consider na natin yung mga corresponding angles. So, angle natin dito, no? Gayahin na lang natin is ito. So, titingnan natin, no? So, kung angle natin dito is 36.87, basically, yun din yung magiging corresponding angle niya doon sa may kabilang side. So, kung ito is 36.87, ito is also found to be at a value of 36.87. So, kung ito is 36.87, 36.87 to. So, in both cases, yung angle natin na gagamitin is 36.87. So, lagay natin 36.87 degrees. So, 36.87 degrees. So, to prove kung tama yung mga values natin, so, ang gagawin natin dito is guys, pinost ko lang muna, no, kasi meron mga nagra-rumble dito sa aming silent neighborhood, no. Pero tuloy na rin natin. So, for checking purposes, lagay natin checking. So, checking. So, lumalabas terms of, let's say for example, horizontal equation tayo. X equation, all forces going to the right are considered to be positive. So, lumalabas 13.5. Area of x is negative. Then, AB of x going to the left. So, negative then. Tapos, si AD, pag breakdown natin yung kanyang x component, papunta sa kanan, so positive. Positive AD of x is equivalent to 0. So, in this case, lumalabas, you have negative 13.5 minus AB 19.95 cosine ng 36.87 plus AD value, you have 36.824 cosine ng 36.87. So, this one should be equivalent to 0. So, check na lang natin kung magsisiro nga siya. So, negative 13.5 minus 19.95 cosine ng 36.87 plus 36.824 cosine ng 36.87. So, ang value natin is negative 8.18 times 10 raised to negative 4. Negative 8.18 times 10 raised to negative 4 is almost equivalent to 0. Or, in terms of yung decimal value niya, yan, negative 0.000818 almost equivalent to 0. So again, yung logical explanation nito, no, since yung mga ginagamit natin values ay rounded off at hindi true value, so andun talaga yung tendency na hindi siya mag-0. So, check. Yan. So, last one, to conclude our discussion, no? So, gamitan naman natin ng vertical equation. So, tatlo ulit. So, in terms of yung vertical equation, summation forces vertical, all forces going up are considered to be positive. So, area of y going up, so positive siya. So, AD of y going down. So, AD of y, yung y component niya, pababa. Negative AD of y. Then, last one is yung y component AB, pababa din. Negative AB of y. So, since wala na, is equivalent to 0. So, area of y, you have positive 34.059 minus AD value. AD value is you have 36.824. Tapos, sine naman, no? Pagka y, sine, tapos 36.87. Then, minus AB value, you have 19.95. Sine, once again, ng same angle, which is 36.87, is equivalent to 0. So, check na natin, no? So, 34.059 minus 36.824 sine ng 36.87 minus 19.95 sine ng 36.87. So, yung value is negative 5.48. Negative 5.48 times 10 raised to negative 3 almost equivalent to 0. Or, yeah, negative 0.00548 almost equivalent to 0. So, ayan. So, base doon sa mga na-obtain natin values, the said values obtained are said to be correct. So, check. Ayan. So, to conclude our discussion, tatabulate na lang natin, no? So, para for presentation purposes. So, ang AD value is 36.824. 36.824 kilonewton, tapos via tension. Tapos BD, you have what? BD is 27.565. So BD is via compression. Tapos you have AB value is you have 19.95 gamitin ko. Tapos via compression. Ayan. So BC naman, so sa BC is you have 16.871 as well as CD. So 16.871 so 16.871 kilonewton. So BC is under the impression of compression, samantalang CD naman is under the tension. So compression, tension. Compression, tapos you have tension. So ayan. So dikit lang natin yung ating tabulated data. Ayan. So, pakita ko lang yung solution na na-generate natin, no? So, ito yung first page, then yung second page, third page, then last page, no? So, ayan. So, again guys, po-provide ko yung pinaka PDF file nung solution natin for you to have a copy, no? So para habang binabasa nyo yung solution, habang pinapanood yung aking tutorial video, mas madali siyang sundan, no? So yun nga lang guys, no? So just in case nagustuhan nyo yung presentation or naintindihan yung concept regarding sa method of joints, so request ko lang is paki-like yung button, and yung pinakamahalaga guys, no? Kung hindi pa kayo nakasubscribe sa aking channel, so subscribe kayo sa channel ko. Yan. So yan. So anyway guys, so in the future meron pa akong ipopost ng mga problem. So nakakadalawang problem tayo sa may method of joints. So dadagdagan pa natin ng 1 or 2 more problems. So iba-iba naman yung sequence o yung klase. So yan lang guys, Thank you for listening.